When we started the project, we wanted to create a robot that would detect motion in front of it and then align itself pointing at the object in order to fire a projectile at it. To do this, we needed to get an input from the outside world, pass it to a computer, and then from the computer pass it back to the outside world in the form of motors which control where the turret itself is pointing. The input from the outside world, we're using webcams, which just provide a simple picture, and the computer can crunch numbers on the matrix that is the picture and figure out what angle to point the turret, both vertically and horizontally, in order to be properly aligned with the object that's moving in front of it.
In order to interpret the data from the webcam in a fashion that will allow us to aim at a target, we need to run some math on it. The most basic is motion detection, in which we take the current frame and the previous frame, then we compare the differences between the grayscale versions of the images, and based on that we can determine how much each pixel in the image has changed since the previous frame. And then detecting the pixels that have changed the most, we can therefore determine that that's where an object has moved. Then we do some weighted averaging, and we can determine where, which coordinates the object is at. Then with trig, we can determine which angle to tell the servos to move to point at the object. Another version of that is called background subtraction, where instead of comparing the current frame to the previous frame, when the turret is turned on, we take a picture of the background. Then each current frame is compared to the previously taken background, which is more reliable because it doesn't rely just on motion detection. It will detect any kind of stationary object that has appeared since the turret was initialized.
While this is a working prototype, it's still just a prototype. We're using quite a few borrowed components, most notably a computer. In addition, the turret is completely made from wood, but by fabricating it from metal, it would be presentable, it would be more professional, as well as it would increase precision. So given adequate funding, we could easily make these improvements well before Rutgers Day.
By presenting at Rutgers Day, we hope to not only showcase the practical application of our classroom learning, but also to increase enthusiasm for both engineering in general and engineering at Rutgers in particular. To be honest, we started this project because we thought it would be a cool thing to do. However, we not only learned that custom CNC milling is really, really expensive, but we also broadened our range of engineering skills and taught ourselves the practical aspects of engineering that can only be learned through experience.